Good morning, everybody, and welcome to today's webinar about the DDoS attacks. I will do a short intro about the Thales team at Exclusive Networks and also a bit of who are we as Exclusive Networks. And then my colleague Charles at Thales will make sure that you know everything about how to stop a DDoS attack. So at Exclusive Networks, you could go to the next slide, Charles. We have a dedicated Thales team. First, we have Davina. She's our marketeer. We also have technical people. Our main technical person is Cedric. We have our inside sales, Nathan, and I am Gronia McGraw, and I'm the business development manager for Thales at Exclusive Network. Now, at Exclusive Networks, we want to make sure that we can help you with marketing services, but also the design, the deploy, several services to help you to gain the deal, whatever the deal is, the deal size, it doesn't really matter. And to make sure you get the correct design, we work very closely with Charles and with the rest of the team at Thales, sorry. Now, the next slide, I will just a very short introduction about Exclusive Networks. I am, as the BDM for Thales, responsible for Belgium, but also for Luxembourg. Of course, we are a global organization, and we want to have a local sales, but a global scale. I just wanted to mention this because it's very important for bigger deals that we can help you on a global scale as well. We have a lot of technical people in our portfolio. This slide is only about Belgium. And I wanted to pinpoint that we only have the best-in-class vendors. That's also why we work very closely with Thales, because they have the best solution for their niche environment. So about AppSec, DataSec, EIM, CIM, they are the best. So that's why we really wanted them in our portfolio. And that's we have a lot of technical people who can help you with whatever you need to make sure you get the deal. As we all know, it's very hard to find skilled people, and there we can help you make the gap smaller, and by delivering worldwide, we can also help you. But we're not just a distillery. We really want to add value. We want to make sure that our mission and our vision becoming the best cybersecurity specialist and make sure that we can secure all your partners and your end customers. And now I will give the floor to Charles to talk about how to stop a DDoS attack.
Thank you, Brona. Hi, everyone. Just making sure that everybody is here and aware. So if you just can say hi in the chat, it would be very helpful for me to make this more interactive. As we all know, going in a virtual environment is always hard to make sure that people are there. So my name is Shyness, based out of the Netherlands, hailing from the Netherlands. So if you want, put it in the chat where you're hailing from, would be nice. I live in a small village called Pijnakker, and today I'm going to talk about protection at the digital edge. And then, yeah, what we say is unified defense with real-time DDoS resilience. What does that mean? So let's have a look at it. So I see Franco, hi from Amsterdam, good to see you. Yeah, the digital edge, so the new battleground. So what is that about? So basically, it is all about, organizations moving their services online to provide services to their customer or business to business. But with moving to the new environments, adapting new technologies, there's a rise in usage of different applications, different technologies. But those are supposed to be used for business benefits or integration with the customers or business partners. But with the rise of, let's say, use of APIs, web services, data on the web services, there's also a rise of attacks happening on those APIs and applications of bots and trying to get access. What we also see is that the threats are moving faster. So AI, for example, everybody is using AI now. Cyber criminals, they have found this as well. So basically, they understand that traditional solutions might be able to stop static things, but they need to be more dynamic. So they need to be able to adapt to new attacks. So this is where the threats are moving faster. A lot of automation is being used in that sense as well. So that means that the defense battling those new cyber criminals, you need to work harder, you need to be better, you need to be faster, and you need to be stronger. And as of Imperva threat research report that we have seen from 2024, so this is a threat report that we look at automated threats that happened in the last year. It's available to everyone on this call. And it's what we've seen for the first time is that the more than 50%, so 51% of traffic nowadays on internet is non-human traffic. That's the first time in the past years that we have been monitoring automated traffic and human traffic, that the automated traffic has exceeded the amount of human traffic. So that means that a lot of bots are connecting to websites, but not only at websites, but also think of APIs trying to get access to data. And what we have identified from the automated traffic, that from the 51% of automated traffic, 37% of the traffic is malicious. So basically, the cyber criminals are trying to get access to data through web services or through APIs by using automation in combination with AI as well. So with that, what we see is that different kind of multi-factor threats are at the edge. And so we see, for example, volumetric DDoS attacks on one side. On the right side, we see application layer DDoS attack, and where the volumetric DDoS attack really attacks the infrastructure. The application layer attack, layer 7, attacks the application or the service itself. But in between, there is also API abuse and exploits and advanced bots. So what I like to do here is to make it more to the point in how this relates to what we understand, what is a volumetric DDoS attack. So basically, it really comes down to, so here, for example, we see a road with 3 fast cars, but the road is unusable for the fast cars, which is full of sheep. So a typical example how a volumetric DDoS attack would appear in the digital world. On the other side, if you look at the application layer 7 attack, it really comes to, let's say, an overload of a server can handle. So in this picture, for example, you see the mule is trying to, it needs to move the carriage, but the carriage is too much, so it's not able, so it has an application layer overload. So this is a good example. And then in between, we've got API and advanced bots. So I always like to use the example, if somebody on the call has, let's say, a pet at home, and you want to lead for example, a cat is a good example, and you want to lead the cat in and out of the house, then you have to either open or close the door. And what a lot of people do, they create this little door behind it, under the door, and then basically then the cat go in and out by himself. But not only the cat can use that, the neighbor cats can use it as well to go in there. But this is more like an example in how, let's say, automation, like APIs, how we can have different services running in there that can be abused by other parts that you haven't counted for. And an example on this picture is you see a lock on the door. So you have your identification and so on, but you have the APIs where services can go in and out, but not only the services for your customer, but also third party that shouldn't have access to that data. They will be able to access that as well. So that's an example how APIs will add positive impact on integration with services that you would provide to your customers, but criminals will abuse those services as well. And then looking at, for example, malicious bots. So malicious bots is what I like to relate to. For example, a bot can be related to like the vermin that creates a nuisance. So think of the fact if you have, let's say, ants walking around, you have this trail of ants either in your home, in your garden, and going after your food. So basically it's going after what is important to you, and it creates a nuisance as well to be able to enjoy the fact that you're sitting in the garden or making sure that your food is safe. So this is how I would like to relate to how a volumetric DDoS, application layer 7 DDoS attack, how API adds value but can be abused as well. And then because all the services are available, that non-expected creatures like vermin or rats or cats are abusing that. Just making sure that we translate the physical world to the virtualized world, because this is basically what's happening. Now, and this is basically where Thales with the Imperva solution is focused on and bringing the best solutions to our customers. and leveraging our partners to be able to do the same. Now, if you're going to focus on the DDoS threat landscape, what we see is that, for example, a lot of botnets are being used, and for that, IoT, Internet of Things devices are being used, because those devices are being deployed. They have the default passwords. They're not always patched to the latest version, so vulnerabilities are available. So it's easy for cyber criminals to get access to those devices and abuse them for providing a DDoS attack, right? What we also see is that multi-factor attacks, dynamic attacks. What does it mean? It means that a attack can happen starting with one protocol, just to say so. And what happens then is that the attacker decides to add some more other protocols. Why do they do that? It has to do with the fact in what kind of DDoS solutions the customer has in place to be able to mitigate that. And what you see is that some of those solutions, they need 10 to 20 minutes of detecting that a DDoS attack is happening. And if I start with a DDoS attack that is, for example, on protocol X, and I start a DDoS attack after 10 minutes on protocol I, that means that that solution, if it was able to detect for that specific protocol a DDoS attack is happening, is able to mitigate that. But if I start an attack with a different protocol, then that DDoS solution has to start again discovering, okay, what kind of protocol is that? Is that really DDoS, and is able to mitigate that? So, and those solutions we see that are struggling because they're not able to mitigate against it. So that's an example of a multi-factor attack. But we also have seen, especially during COVID, is that random DDoS being used, right? People working from home, people connected to VPN concentrators. That was an opportunity for attackers to attack those VPN concentrators. So this would be an impact to the organization because people were not able to connect to the services, do not perform their work, and that results in all sort of bad impact on the business results of the organization. So random DDoS was being used as well. If they don't pay, then they will do a full DDoS attack and then cripple the entire organization. I'm going to skip over to the smoke screen. We have seen that as well. Just a step back before I go to the smoke screen, we have seen this as well. So Imperva as an organization, and now part of Thales, what we have seen is that DDoS attacks were used as a smoke screen as well. How did we identify that? As part of the application protection that we all provide today, we have also a data protection happening as well. And what was happening is that an organization, they had infiltrated an organization, and basically they wait for the right moment, like ransomware, right? They wait for the right moment. They just need to make sure that there's no distraction being done by doing a DDoS attack. And what we see that if an organization doesn't have a good DDoS protection in place, that all focus of IT security personnel go to the impact that is happening to the organization, focus on the DDoS, and that is the moment that cybercriminals has the opportunity to steal data without being noticed and walk away from that. So it's being used as a smoke screen as well. And then going back to the pulse attacks, actually the same as the multi-factor attacks. While the multi-factors, the attackers are using different kind of attack methods. With the pulse attacks is what happening. They can use also the multi-factor attacks, but what they do an attack maybe for 5 minutes, they stop the attack, wait again, start again with 5 minutes or 10 minutes attacks. So this comes back to the solution that the customer has. If the solution needs 10 to 20 minutes to be able to identify if DDoS attacks is happening, if the pulse attacks is like 5 minutes of, let's say 1 gig of attack, and it's not able to determine if it's DDoS attack, that means that the bandwidth is not available, and with that, the attackers are able to cripple the organization as well, and they can continue doing that as long as they want. Organizations, they can come back from that, but can take sometimes 1 to 2 weeks to recover from those kind of attacks, and this is why the DDoS is a big problem for a lot of organizations. All right. Yeah. So that what does it mean? That means that it creates downtime for the organization, and downtime meaning is cost. Of course, reputation damage, brand loyalty. Customers might move away to the competitors. Yeah. What you also see is legacy systems are not built for more than DDoS attacks. Because they have infrastructure issues, they have legacy routers that try to do it with traditional solutions, and that's not sufficient anymore to be able to mitigate against those DDoS attacks. What you also see is that the best practice is also to make sure that the DDoS attacks is being stopped right at the course, not let it come to the infrastructure of the organization, because when it comes to the infrastructure of the organization, then it might be already too late to be able to mitigate against those DDoS attacks. Of course, incidents recovery costs, as you have to fix everything, recover everything, those kind of stuff will be impact to the organization. If a customer has cybersecurity insurance costs, that might be increased as well. And then, of course, compliance issues, so SLAs and KPIs might be an impact as well. And this will be impact to the customer, and to be able to limit the cost, they need to have a good solution to be able to mitigate that. With that, it brings me to the Imperva Unified Edge Security Stack. So what you see here is actually a global presence of the Imperva POP data centers around the globe. And these POPs are growing more and more. And what you see, what we provide in this POP, this is really unique to the Thales Imperva solution. So what you see is that we have a single POP, and to be more technical, in the POP we have 4 components. The 4 components is a router, a switch, a proxy, and what you see here is a reverse proxy that we have in our POP running. And the last but not least, that's what we call the behemoth. And the behemoth is a hardware defined by our R&D. It's not available for purchase. It's running our data centers. And what the behemoth does is basically scrubbing all the traffic. So when the traffic comes in our data center, it goes first to the behemoth. The behemoth checks if there is any layer 3 for DDoS attacks going on, and will send it on to the back end reverse proxy. And the reverse proxy includes, for example, advanced port protection. So you can see in this example, in this picture, API security, the cloud web, client-side protection, and those kind of services are being offered as what we call the unified edge security stack. And we believe this is important because with the attacks that we have seen in my introduction, you saw that talk about layer 3, 4 DDoS attack, application layer DDoS attack. And what you see in the layers that we provide here, we have different engines where the DDoS protection can protect against layer 3, 4 attacks, but then you have DNS that can circle from layer 3, 4 attack, but also from layer 7 attack. The same for advanced bot, so automated bots connecting an application, API, they integrate with the application. They don't necessarily create a layer 3, 4 DDoS attack, but they can create a lot of nuisance on the server itself, on the application itself, but they can also generate a lot of traffic. And this is where we see that having a unified security stack is important to be able to identify if a real DDoS attack is happening layer 3, 4, or if the customer is having an advanced bot problem, because you can imagine that an advanced bot is connected to a website and can create a lot of requests to the server itself, but it creates also a lot of traffic. And we have seen in our experience, a lot of customers, they believe with not the right solution in place that they have a DDoS problem. What we normally do, we onboard our, let's say, cloud web solution that includes the advanced bot protection. And by looking at the traffic, we were able to determine, is this really a layer 3 for DDoS attack happening on the customer website? Or is there a different problem going on, like an advanced bot protection? And we see that more and more. And then, of course, API security. And we use the cloud web for not only protecting the web application against the OS top 10 attacks, but also mitigating layer 7 DDoS attacks as well. And then last but not least, client-side protection, which is part of the PCI DSS requirement, like the cloud web as well. And we provide that as a centralized solution to be able to determine what kind of servers are running on the client without the need to deploy any agents or services on the client, to determine if there's no third party trying to get access to confidential data and harvest that from the client side. This is what we can provide with our single POP. And part of the solution, what we have also is CDN. CDN as part of the solution. And on the other side, we have a load balancer where you can load balance only for the web protocol, so HTTP, HTTPS, either on traditional data centers, on-premise, or in cloud services. And on top of that, what we have, what you can see at the top, it's not very clear. Let me see. You see analytics. And the analytics is basically understanding all the attacks that are happening on the different layers. What we do, we create narratives, attack narratives for that. So basically, it drills down from 100,000 events or alerts to maybe 10 critical incidents. that a SOC team can look into and take actions upon that, and that makes make sure that the organization is on top of the threats are happening to their organization. I'm just checking the chat. If there's any questions, feel free to put it in the chat, and otherwise I'll just continue. Yeah, all right. I see nothing else. I'll just continue. Yeah. And just what I just want to highlight is a different representation of the solution that we have. So just to make sure that we are on the same page here, the solution that I'm talking about that Thales provides us today is a solution in the cloud. So it runs as a service. So no deployment at the customer site is required. We do that for the DDoS protection. We do that for the DNS protection. And we have a secure CDN. So this is what we call the network security. Let me just highlight that. And then as part of our software as a service solution, we have, of course, the web application firewall combined with the API protection. We call it according the web application API protection, bot protection, mitigation against the persistent bots, API security, advanced bot protection. And then what we still provide as the customers require that, and this is normally customers that I have an on-premise solution, or they have an on-premise data center, or they have services running in the cloud, and they don't want to have the traffic going to a cloud service, then we still provide, as of today, what we call the web gateway. That's some virtual appliance that can be deployed either on-premise or in the cloud. And what we have also some runtime application self-protection. And these solutions that we as Thales are focused on is indeed on the network and on the application. But the main reason why we focus on these types of solutions is that it provides access to data. And there it doesn't stop. There we don't stop as an organization. We are really a data security company. And basically what we do, we focus on any path that provides access to the data, and we provide cybersecurity solutions against those. Basically how I like to frame it. So the network security, application, API security will protect the front door, but then we have, let's say, the insider threat inside the organization, where you have insider threats, where privileged users can be abused. Think of employee data can be stolen, credentials being used, compromised accounts that can have access to the data. So we have a solution there that we call Data Security Fabric, Data Risk Analytics, and Data Risk Intelligence that will provide customers insight what's going on within their organization. Okay. Yeah, so why is integration matters? I highlighted that a bit as well. So if we look at traditional siloed tools, it creates complexity, it's delays, it's pointing to each other. So the example that I gave, right? So if an automated bot is trying to attack a website, it might look like a DDoS solution if you don't have, let's say, unified stack as we provide today as Thales. Then basically organization might not be understanding what's going on, what the threats are. And they might be using different type of methods to be able to mitigate against those kind of attacks. With the Imperva unified stack, we provide speed, simplicity, and visibility. We do it harder, better, faster, and stronger. And then part of the solution we have built in, I must say, global threat intelligence. So we have at the moment more than 200,000 websites that we have under protection. We have intelligence that we get from the traffic that we see in the customer environment. We have also what we call sensors, network sensors running on the internet. To be more technical, is that we are tier 1 connector. So that means we connected directly to the internet. And with that, we see a lot of traffic. The traffic is going into our SD-SOC enabled network. And there we analyze all the traffic, and we still have analysts looking actually to the traffic. If it's being highlighted that's traffic that we haven't seen before, then it's going to be updated either through AI, or we still use human intelligence to be able to identify, okay, how do we need to update our engines to provide the best protection for our customers today. So with that, I'm going to provide a live demo using Red Wolf. I'm not sure if everybody is familiar with Red Wolf, but Red Wolf is an authorized tool also recognized by Azure, by AWS, to test infrastructure against DDoS resilience. What I will do, I will launch the Red Wolf tool. We will look at it. I will look at my infrastructure, and then we look at the Imperva dashboard, how basically the Imperva dashboard blocks malicious traffic in real time. So just checking the chat. Are we okay to look into the live demo for that? And it's always interesting to see if the live demo works out right. Just share my screen. Just give me a moment. Yeah, here we are. Okay. So I'm just going to highlight quickly the environment. Grona, you can see my screen, right? Just making sure.
I can see your screen, yes.
Exactly.
Very clear.
Okay, excellent. So let me explain what we're looking at. So this is my web server. It's a vulnerable website, a very vulnerable website. This is the web server. And this one is now hosted behind our services. And what I'll just quickly do, just to make sure that we're on the same page, I will show you how this web server is being translated into the service available through the Thales application security solution. So as you can see, that URL points us back to a CNAME. So this is how we provide the services to our customers. If the customer has an existing service and they want to onboard that, so what we'll do, we'll replace the IP address that the customer is using. So if I look at my SuperVida server, it uses this IP address 34.255.0.10, and we will replace that with a CNAME. So that means that if I go into my console, this is my console, and if I go to my web service, this is my web service that I'm going to demonstrate today. And if I look up the website settings, then you will see that once the service hits our point of presence, then it hits basically the CNAME that we have provided. So this is the CNAME that we have provided. It hits the web server, and then when it hits our reverse proxy, then we will redirect the traffic to this IP address, and this IP address is an IP address that's hosted in the AWS environment. This is clear? I'm just checking the chat. I see some questions in the Q&A. Is that correct? Okay, yeah. So that is correct. So we're on the same page. And just to make sure that you understand that this is a well-known website, and what you see also here in the settings of the web service, we identify. So, for example, the original DNS setting for the SuperVida.nl was at a record, and then basically DNS setting for Imperva, SuperVida, and then that is the CNAME, which we can see here is the same that we're gonna replace it for. And this means that the customer has to update their DNS services to change SuperVida.nl from 34.250.1 to this CNAME, which you can read out as well. And then what they need to do as well as a last step is make sure that they update their firewall to only allow the Imperva POPs to have access. And I'll show that here. So in AWS, if you click on the security part, this opens, let's say, the firewall, the inbound rules, and the inbound rules, as you can see, is that these are the IP sources that Imperva has, and only these IP sources will be able to access the services. Yeah. And what I did as well is I made sure that my IP address is accessible as well. So let me see if I can find that quickly. Let's see that here. Just go here. And here, okay. So here, for example, this is the IP address that I'm using today. So that means that I, from my machine, can access the SuperVida service as well. I cannot use the fully qualified domain name that as it's registered on the DNS. For me to be able to connect to that, what I can do in AWS is connect to its AWS naming. So, or I can connect to the IP address as well, but I'll just use the DNS name. And I just want to show you that it's a vulnerable website and that you understand that's behind the surface. So if I look at SuperVida, As you can see, the public DNS name. If I open it, I've added my IP address to the server so I can access it. And just to show you, if I do, for example, a SQL injection here, then the SQL injection is successful because I'm bypassing, let's say, the Imperva service. But if I would do the same on the superpeter.nl, then let me see if this works. It should be blocked by the Imperva services. Just see, there we go. And here we can see that it's being blocked. It gives my IP address. This is the IP address I'm using today. This is one I put this in the firewall, the proxy IP address. So this is the IP, one of the POPs that I'm connected to, and that's the one that's blocking this traffic. Okay, are we on the same page here? Just checking. Yeah, and now let's go into, let's say, the DDoS protection, the 3 seconds SLA. So what I'll do, go back in here. So what I already did to save some time, I've onboarded, let's say, the IP service. So the IP service, how does it work? Again, here, you have seen already that the origin public IP address is 34.255.0.100. I just confirm that. 34.255.0.100. And what Imperva does, the service, is that we replace that IP address with what we call an Imperva Anycast IP. In this case, 45.61.86.21. So the customer has to make sure that those A records are pointing to this, so that if anybody's trying to access the services, they point to the Imperva Anycast IP service. Why we use Anycast IP? The Anycast IP, we use that because we have around, over 60 points of presence around the globe. The question that we get a lot, if you look at the IP address, that IP address is based out of the US. That might be correct. We have other IP ranges as well. But as we anycast it to any point of presence around the globe, it means that if a client is connecting, for example, for Belgium, and they connect into the closest POP, then that IP address will be available to that closest POP. So they don't have to go to the US completely. They can connect locally, and then basically they will be able to access that. So in my attack, what we will see, I will do an attack with the Red Wolf tool, and we will have, let's say, attack agents running around the globe, and they coming into different in different point of presence, and all those point of presence are serving the same IP address. Just making sure that is clear. Is that clear? All right. I assume that's a yes. So what I'll do now...
We don't have any questions, so I think everything is very clear.
Clear. All right. Just making sure that we're on the same page. Yeah. And then if I look at the dashboard, and you need to understand this is, of course, a cloud services. So this is real-time data. And what you will see here, for example, it says no data coming in. It takes some time to updating. It's real-time, it's set to real-time. If I put it, let's say, to last, let's say, 30 days, it will get, let's say, all data in there, and I'll just put it to real-time. And for the real-time data, basically what's happening, it's gathering all the data from the POPs around the globe, get it together, and trying to show it in real-time. So it says real-time. What I like to say, it's close to real-time. There's always a bit of delay. Now let's go back to the attack tool. So this is Red Wolf. And before I go in, I'm going to explain this. Let me look at the agents. Yes, let's go away. So before the session, I have deployed some agents around the globe. And here we can see that we have agents that are going to be used to do the attack around the globe. And you will see the countries like USA, Australia, Brazil, Netherlands. Those are the locations that are going to be used to provide the attack. And here you can see the number of agents. And with that, I go to my predefined attack schema. And what you see in my attack schema, I use the IP address 45.60.186.21. So that's the one that we have defined for that Imperva has given to in this case the organization 45.61.86.21. And this is where we're gonna provide the attack on. So at the moment, it's let me just go back. Sorry. Okay. Yes, there we go. Let's go to the dashboard. And I'll leave the dashboard running. And basically, once we start creating traffic, we should see some real-time traffic coming in. Now here we've got different kind of polymetric DDoS attacks that we can provide against the server. That's this one. Let me just make sure that the server is responding. There it goes. It's working. And what I'll do, I'll just start with an ISMP plot first. Let's do that. And what I'll do now, I'll just start the exercise, and right now the test is running. And then this takes some time. So we see already some traffic. We see now the table being updated. And let me explain what you see here. So here, for example, the bits per second, this is basically the number of, let's say, bits per second being sent to the web server. So now at the moment, I'm creating an attack that is basically an ISMP attack. And if I look at the traffic type, then we will be able to identify, this ISMP mailing that's being sent over to this web service, right? And this side, you will see it is the bandwidth that's being attacked, so the bytes per second. On the other side, what you will see is the number of packets being forwarded. I'm going to ask a question if somebody knows it. If not a problem at all. So where this is the available bandwidth, so if the customer has, let's say, a 50 meg pipe, then in that case, that meg pipe would be saturated. It will only be able to respond. So this is really attacking the available bandwidth. The packets per second doesn't necessarily attack the bandwidth, but attacks other resources. I just gonna ask the question, anybody, any idea, the packets per second, what components can be affected by the number of packets per second? And this is the available bandwidth. So this might be your pipeline to your ISP. That can be 50 Mbps. But this is basically, I'm gonna say it anyway. This could be your routers, your reverse proxies, your firewalls. Indeed, Franco, thank you for the answer. Not necessarily server resource could be, but normally this is attacking the infrastructure components. So the routers, the switches that need to forward the packets. If they're not able to handle these number of packets, then they can be saturated as well. So two types of attacks are being mitigated against here. So let's see what's going on with the web server. The web server is still there, still running, still responding, can still do some other stuff. And let's make it put harder. So now I did an attack, and the attack is now going on for a couple of, at least two minutes approximately. And what I'll do, I'll just add a new attack vector. So let's do a UDP plot. Randomize, let's do that. Randomize destination ports. So basically different kind of ports, and then we'll add these one as well, and there as well. And then I still got the traffic type, so we should get more different traffic types in. And this again, and this is where the 3 seconds SLA, we see some fast traffic going in, but some of the other traffic will be mitigated again. And now we see that I used a dynamic destination port. So depending on the destination port is being used, is being identified as NTP, UDP, or DNS, because you use a dynamic destination port. And based on that, is be able to identify what kind of traffic type is going in there. And as you can see, the peak traffic is going higher at the moment. Packets per second are still the same. And let's look at the website. And the website is fortunately still responding, right? And with this, we can do some other attacks as well. Now why not stop the attack? So let's say a pulse wave attack, right? So we do a pulse wave attack. We stop the attack. We should see the attack going down. And here we can see immediately, again, I said it's close to real time. The service responds within 3 seconds to mitigate against DDoS attacks. And now we see that the traffic is going down as well. All right. Let me just start again. So again, a pulse attack. So this is an example where if a customer has an existing solution that needs 10 to 20 minutes to do a DDoS attack. And so if in this case, I have done it only for 2 minutes, so I've stopped the attack and now I start the attack again. So doing I do combination of multi-factor attack and a pulse wave attack, and now studying attack again. And then basically, if I would use a different protocol as well, so I could do that as well. So let's take analysis plot or a SYN plot. Let's do that one and remove this. So a combination of a pulse attack and a multi-factor attack. So that makes it more complex. And basically, let's look at the dashboard. The attacks are, so this traffic will increase and will be mitigated against. And while it does that, so what we also provide is different insights. So we can look at the traffic type. But what's also interesting is the IP addresses that are being attacked. So in this case, I've got only one IP address. We have, for example, what we call the network protection. The network protection is really a BGP-based DDoS protection that we provide. So if a customer has their own C-class range, their own AS registration name, then basically they would onboard their C-class range. And basically, based on that, if we would look at the IPs, we could see what kind of IP range is being attacked at the moment. And we can do all sort of, let's say, sophisticated redirecting of the traffic. If some traffic needs to be whitelisted and being sent forward, all those kind of complex configuration can be delivered with that as well. And so beside the IPs, let's take a look at the point of presence. So basically, as said, right, we have seen that the attacks were happening from different locations. So in this case, we have Frankfurt, Amsterdam. I don't know from the top of my head what these are, Paris as well. But we have a list of POPs. These are the abbreviations of the POPs that we around there. So you can see which of those POPs are being included in mitigating the traffic, right? Interesting thing is that, for example, the Singapore POP is mitigating, for example, some of the packets that are being directed to that Singapore POP as well. With that, let me just stop the attack. I think I have shown everything that I wanted to show. What you see also here is the POPs that are being mitigated. If I look at the traffic type, you see all kind of analysis as well down here, and the amount of data is being used for different traffic types. And then, of course, if there's attack being done, we also provide insight to analyze the attack as well. So, and the analyze attack gives information like source IP, destination IP, destination ports, source ports, all those kind of the service being used, all of kind of insights is being given as well. All right. I think that with that, I want to conclude my demonstration and just quickly refer back to the slide decks that I still have some of them here. Let me just see. Share content. There we go. So we looked at the DDoS tool. Now, also what happens is it creates also a real-time alert. So at the moment, I should have received an email address, an email with the alert that a real-time DDoS attack is going on, but I don't have to take any action on that. There we have case studies available online. You don't have to subscribe to that. And this is a case study of customer fintech. They wanted to validate they are resilient against 3 terabytes per second DDoS attacks. They use Red Vault as a testing tool. And then beside the DDoS protection, they are using the advanced bot protection as well. And they were able to mitigate 98% of the bad bot traffic. This report is available in our case study. If you're interested, you can look at that. Yeah, and just quickly, what sets Imperva apart. So we have an always on 13 plus terabits per second DDoS protection, 3 seconds SLA. You have just seen it in real time. Be able to mitigate against pulse attack, a multi-factor attack. We unified console to be able to determine what kind of cyber attack a customer is facing. We believe you need to have a unified console just to make sure that we have the right protection in place. And the SOC that we have is 24/7. We still use humans. We call it the SAS service, stands for Security Analyst Services, to create custom policies. The Security Analyst Service is mainly used for the advanced persistent bots that we see that customers are facing. There are some case studies for that as well. If you go to our case study on the portal, there is a customer called Amadeus. They are reference customers. they use on a daily basis our security analyst services to mitigate against the most persistent bots. Unified edge security, so no single point solution, quick resolution of incidents, and yeah, we have proprietary hardware. The Behemoth, I mean, I call it already out. That's our DDoS protection. All our traffic goes to our Behemoth machine, scrubs all the DDoS traffic. And the first customer I always highlight that they defend for the traffic is the Thales infrastructure. Thales infrastructure is by default protected with our DDoS solution. Okay. Yeah, final takeaways. So simplicity, speed, and full stack security. Red Wolf is able to show the real-time resilience for multi-factor DDoS attacks or pulse wave attacks. And we have a free DDoS Cloud Web API advanced bot trial available. That's the link. And with that, I want to thank you for your attention and your interest into Thales and exclusive network customer day. Back to you, Grona.
Okay, thank you very much, all. If you have any questions, please don't hesitate to contact us, me or Charles. I also wanted to point out that nowadays it's very important that the fact that Thales is a European company, that's also a big point nowadays for many of our partners that we see is very relevant, important with all the problems in the world. So I just wanted to point that out one more time. So if you have any questions, please ask, please contact us. There's, I'm open for all questions.
Yeah, thank you for pointing that out, Grona. Yeah, that's indeed a good point. We're a European-based company now, and that's what we see a lot of requests coming for as well. It was a pleasure to be here on the call, Grona. Thank you for having me, and looking forward to meet all of you in the future.
Okay, thank you very much, all, and hope to see you soon.